back. So far we learned about process control mechanisms. We also covered how can we reduce defects with the help of Poka-yoke, TPM and other lean tools, as they enable better flow of the process and so the value as well. Now in this unit, we are going to learn about statistical process control, which enables a process to statistically indicate issues and thus on constant monitoring, we can keep the process in control by eliminating factors leading to out-of-control process. We know that the output of any process has some amount of variation. In statistical process control, we make use of control charts to monitor this variation on an ongoing basis. Walter Showart proposed the idea of control charts. Control charts are a graphical and visual plot of a process and charts over time, like a time series chart. The control charts have vertical axis, on which the value of quality characteristics are plotted, and the horizontal axis represents the samples, or subgroups in a chronological order. Here we can see a typical control chart. The red lines are control limits, and green line is the process center or process mean. If any observation goes beyond the control limit, that is an indication of potentially out of control process. The control charts serve following purposes. A control chart indicates when something is wrong with the process, thus triggering corrective actions. The pattern of the plot diagnoses possible causes and hence helps in finding possible remedial actions as well. As we know, capability analysis should be done only when process is in statistical control. Control charts are thus used to assess if a process is under control or not. We also know that the variation is a natural phenomenon. Over-control through frequent adjustments only increases variability. It is thus better to use control charts and make adjustments only when there is any indication of out-of-control process. The causes of variation can be divided into two types: common causes of variation and special causes of variation. The variability due to special causes of variation is something that is not inherent in the process. It is not part of the process as designed, and thus it doesn't affect all items. It can be due to improper use of any tool or unsuitable raw material. The variability due to common causes is something that is inherent in the process. It is part of the process as designed and thus affects all items. When the variability is constant, we call it a stable system of common causes. The process under this stable system is known to be under statistical control. The values of quality characteristic or the statistic plotted on control charts are assumed to have an approximately normal distribution. For large sample sizes or for small sample sizes with a unimodal and symmetric population distribution. The central limit theorem states that if a plotted statistic is a sample average, it will tend to have normal distribution. This signifies that, even if the parent population doesn't have a normal distribution, control charts for averages and other such statistics are based on normal distribution. The upper and lower control limits help in decision making. The limits are chosen so that the probability of the sample points falling between them is almost 1, usually 99.7% for 3 sigma limits, and given the process is in statistical control. As we have seen in earlier lessons, control limits should not be confused with specification limits. Specification limits are provided by customer, while control limits are usually 3 sigma limits calculated based on the data points. Control limits represent actual process performance while specification limits represent desired performance. Control charts allow the project team to maintain the process performance improved with the help of a Lean Six Sigma project. There are a few rules which should be followed while reading a control chart. This helps in determining when a process is out of control and triggers necessary actions. The most commonly found symptom of out-of-control process is having a point beyond the control limits. It indicates a large shift in the process. Second rule says, if 2 out of 3 consecutive points are beyond 2 sigma limit at one side, the process has gone out of control. Similarly, as per third rule, the process is out of control if 4 out of 5 consecutive points are beyond 1 sigma limit. Fourth rule says, if 9 or more consecutive points fall to one side of the center line, the process has shifted and is assumed to be out of control. Fifth rule says, if there is a run of 6 or more points steadily increasing or decreasing, the process is out of control. Once we find any out of control points, we must pinpoint the causes associated with these points. This requires a thorough knowledge of the process. It is a collective effort to find the cause. A cause and effect chart can be utilized. Once we have identified the special cause, appropriate corrective actions are proposed and taken. We are aware of various fundamentals and terms used in SPC. Now we will learn about control charts. Here we come to an end to this lesson. Should you need any support, feel free to contact us. Thanks for watching this video, and see you in the next lesson.